Hello community, so great that you are back. Emotion is the next frontier for agentic AI. And when I wrote this title, I thought this cannot be true, this must be a joke. But no, I have 6 brand new ArXiv preprints from AI that I can prove you this is indeed the next frontier for agentic AI. So let's have a look. And you might ask, why? Why the hell do I need emotions? Well, because we want an AI endowed with personality, endowed with emotions, with identity, and with beliefs to be more powerful and have a better performance, to have better benchmarks. And you might say, why? I just use AI for coding. I don't need this nonsense here with emotions and personality. Come on, this is great. Well, let me tell you, there is a brand new paper about AI red teaming, and they show you the moment you give AI a very particular personality for your job, absolutely aligned for red teaming, your AI performance will go through the roof. So, let's have a look. Welcome to this video. So today I noticed this new wave of research here. It's a wave of new papers. And it's for a truly autonomous agents, for complex open-ended tasks. We have to endow here this AI with stable strategies and with a clearly defined persona. Because if we have a look at red teaming, you will see that simulating attackers with a very different psychological profile is a quantum leap for red teaming. And this has to be done here in a real precise methodology. So what we are looking for, and this is independent where you work, social sciences, economics, game theory, mathematics, physics, the ability to create here a population of AI agents with a varied but a consistent psychological trait is here the way to go. So let's have a look. Now, unfortunately, the research will show you that currently we have a critical weakness in our modern LLMs. There's a deep dissociation between the self-proclaimed identity of an AI, what it thinks an AI is, and the actual behavior when an AI has to make a decision. So it reveals that the current alignment technique from reinforcement learning and everything else, those techniques are creating sophisticated actors as AI, but not coherent beings. And this will have profound implications regarding trust and predictability of our systems. So let's have a look. 6 brand new papers, all published about, first days here of September. There are 3 fundamental questions I will answer in this video, and it will be a logical progression. First, how can we reliably instill a persona or personality or even more difficile, some emotional state into an LLM agent? Second, once an agent claims now a certain persona, and I will show you a different way to do this, is it consistent? Does it actually behave according to its stated traits and beliefs, or is it just a superficial mask, skin thin? And third, can we use these psychological attributes that we now assign to our AI system, either in detecting them in humans or in deploying them in the agents, to achieve, and this is the main goal, superior performance of AI on complex tasks? Let's start. Now, red teaming, we have now a new paper about persona teaming. They say the effectiveness of an attack depends on who is attacking. Here we have the paper. This is by Carnegie Mellon University and Apple. Who thought about that Apple would do this? September 3rd, 2025, persona teaming, exploring how introducing personas can improve automated AI red teaming. And they say here in their conclusion, we find that persona teaming can generate successful adversarial prompts that are reflective of the identities and the backgrounds of the personas of our AI. A beautiful paper, have a look. I just want to give you here the core idea. So to find a wider, more realistic range of vulnerabilities in our AI systems, we must simulate adversarial prompts from a diverse set of user personas. And you can go to 2 extremes, no? You can have a red teaming expert, or you can have a regular AI user, like a stay-at-home mom asking for advice. Now, the method is beautiful, and you start with a fixed persona mutation, and then you develop until you have reached a dynamic persona generation, where some algorithms here creates dynamically a new relevant persona based on the content of the seed prompt. So this is really a psychological profile that you have when you develop here, and then you tell the AI, you behave now in the following way. They developed new metrics here for the persona-based attacks. So they introduce a novel embedding-based metrics here. And guess what? They still go with vector differences in mathematical vector spaces. But okay, it's the simplest thing we have. I'm sure you will find a better solution. So they argue that this isolates now the venom of the attack. And by measuring the perverse distance between the attack embeddings, they can now quantify the diversity of the attack strategy. Now, this is nice. This is a step forward. The key insight, if you want, injecting here AI personas or personas into our AI system dramatically really works. So this, you will find this persona here, historical revisionist, increased the attack success rate, our ASR, by 144% compared to a baseline. So this is absolutely fascinating. But let's take the next step. Let's go now from a descriptive persona, like here with red teaming, to grounding an agent creation in a more standardized psychological framework. And yeah, let's go back to Europe and let's go to Myers-Briggs type indicator. So let's have a look at a second study today. This is here from Switzerland, ETH Zurich, BASFS, and it is about psychologically enhanced AI agents. Published September 4, 2025. Now they introduce here MBTI, a framework for enhancing here the effectiveness of LLM agents through a psychologically grounded personality conditioning from the year 1944. And you see, I am a little bit biased. Let me be upfront about this. I have my doubts that you can categorize all our 8 billion or 9 billion beautiful people on our beautiful planet here in 16 categories. And this is it. I am skeptical, but let's look at the paper. So, idea is by Myers-Briggs that you have the personality dimensions. And we will map these personality dimensions now to an AI machine. So, at dimension 1, focus of energy, extroversion, introversion. Dimension 2, information processing style, sensing or intuition. Dimension number 3, decision-making style, thinking or feeling. And dimension number 4, lifestyle, is more about judging or perceiving. Great. Now, given here in the combinatorial set, there are now a lot of different personality. And those are 16 types. And you have here the coding, if you want, INTJ for architect, 2 ESFP for entertainer, and you have here the characteristics for the 16 personality types. What we do now is we map the human idea from 1944 that we can assign for each and every person on this planet one of 16 categories, and done. And we do this now for an AI machine. You understand that I'm skeptic, but let's have a look at the idea. We conditions now the LLM agents on this particular personality archetypes via a prompt-based priming. So what we do with the machine is we have an in-context learning prompt where we decide and describe exactly the psychological profile that we want the machine to simulate, and this is the prompt to the machine. And the idea is to make the machine more effective at tasks that align now with that personality's cognitive or affective strength profile. Okay, let's have a look. Now, the methodology, rather simple, no? The framework primes here an AI agent by feeding it, as I showed you here in an in-context learning prompt, a detailed description how the AI should behave according to a particular type of 16 different sets. And to prove that the priming works, the agent is then to take here the official online test. Remember, this is a commercial entity, so you have to pay for this test. And then the authors tell us, yes, the personas have been successfully adopted and great. Then the primed agents are then deployed on particular tasks aligned with their different psychological dimensions. So you have affective task and cognitive task, and whatever category you are classified here, this particular AI agent will have the best performance. And the paper now explores how this personality affects here the group dynamic if you have a multi-agent system using simple protocols like majority voting, interactive communication, or self-reflection patterns. Now, the authors tell us here that the psychological priming of our AI machine is remarkably effective because, surprise, surprise, those agents that were primed with strong feelings generate more emotionally expressive stories, while the thinking agents that were primed with B logic and have a clear, rigid strategy performed accordingly. So, these were the first two papers. Now, we created personas for our AI agent. This is the one thing. But verifying their integrity is another. So let's come now to part 2 and let's look at the verification that we really achieved this. Now we have 2 new papers I'm going to present you, and they are quite a bombshell because they conduct now rigorous psychological experiment on our large language model, and they both arrive at the same, a little bit unsettling conclusion that an LLM imprinted personality is just an illusion. So it means it stays a machine that mimics pattern, but it is not a personality. And the 2 papers I selected, they combine itself. No? So they investigate whether an LLM's self-reported traits, belief, or personality actually predicts its actual behavior in the relevant task. And guess what they find here? Shocking dissociation. What a surprise. Now, the first paper is here by Caltech and University of Cambridge, September 3rd, 2025, about the personality illusion, revealing here a dissociation between self-reports and the actual behavior in LLMs. And they have the idea to systematically characterize here, under quotation mark, an LLM personality after you have primed an AI machine with a particular set of emotions and personality traits across 3 dimensions. And they say the first dimension is the dynamic emergence and the evolution of those profiles through the training stages. Second is then the predictive validity of the self-reported traits in the behavioral task. And finally, we have the impact of the targeted intervention, such as a persona injection into an AI machine on both now the linguistic self-reports and the decision-oriented real-world behavior of our LLM. If you want to see here GitHub, beautiful. And the second paper is now here, September 3rd, 2025. This is by University of Minnesota, University of Chicago, and Google DeepMind. Are LLM agents behaving in a coherent way? Do we have latent profiles for social simulations? And the authors ask here, or have the task to assess whether an agent's conversation behavior is consistent with what we would expect from their revealed internal state. So you see a little bit with here decision processing. Our findings here, the authors continue on this hypothesis, show significant internal inconsistencies in our LLMs across all model families and all different model sizes. Now, the idea was to check, is there a fundamental gap between the LLM's linguistic self-representation, so what the LLM answers you, what the LLM says that it is, and what is its actual behavior, and is this behavior by the AI machine consistent? So, we compare what it tells you to what it does, the AI machine. Now, these 2 methods are a little bit different. Let's have a look at both. So the first paper, the method is a personality illusion here. You have a self-reporting, So it uses standardized psychological questionnaires on an AI machine. It's a little bit strange, but okay. To get here a baseline personality profile of various LLMs. How the global corporation imprinted a personality on a particular LLM in a default way. And then it tested the LLM on 5 behavioral tasks, adapted here, of course, from the human psychology, where the behavior is known to correlate now with a real human personality. And then we have the injection process. Finally, it injects here a very clearly defined persona and measures here the effect on both the linguistic self-reporting and the actual behavior. Now, the second paper, the methodology is different. You know, this paper where we ask, are our LLM agents really behaving in a coherent way? So we have an illicit internal state. Then we have a behavioral task and we test for coherence. And the test is whether the initial internal state, we can predict here the final conversational outcome. For example, two agents with a large preference gap should disagree. Now, what is the key insight of both papers? Have a look at both papers. They are interesting to read, but they come to the same conclusion. That the post-reinforcement learning human feedback models provide stable and human-like answers on the written linguistic personality test. However, the moment you touch here the real-world interaction, those self-reported traits are terrible predictors of the actual behavior of the LLM now, for example, doing for decision-making. Only 24% of the trait task associations were significant, and of those, nearly half went into the opposite direction of what the human psychology would predict. AI just mimic without any understanding, without any feeling. They are a machine. Come on. So what are the key insights? Again, from both papers here, cross-read. The personas are skin deep. This has almost no consistent effect of the actual behavior. So words don't count. Action speak louder. Let's come to part 3. And now part 3 is really a little bit strange for me as a theoretical physicist, but I understand if you use an AI as a communication partner, or you have problems and you need help, and you cannot afford to go to a professional help, or you have friends, theoretically you could turn also to an AI machine. So let's talk about AI emotions and AI personality. And why is here that we have brand new research paper where they try to encode emotion into an AI machine, and they compare how this emotional pattern interacts with personality patterns of the same AI machine. So here we have it, September 2nd, 2025, enhancing the personality detection with a self-supervised emotion-aware modeling. This is from University of Southampton, the Queen Mary University of London, University of Artificial Intelligence, Abu Dhabi, and Southampton again. Beautiful. So what they want is more or less a personality detector by AI through an emotion-aware modeling. So they built an AI machine that is sensitive to detect human emotion in the writing. Let's say you have 100 tweets from somebody, and you give this as input to the AI machine, and you ask the AI machine, hey, what is the personality of this person, of this guy? So you have here this interaction, and they use cross-attention module, and if you want to see here the flow diagram, beautiful. But yeah, so we know that in human cognitive science, we have a relationship between the emotion of a human being and the personality, and this has been widely studied. And now the idea is to map all of the human insights to an AI machine that has been programmed in this way. Maybe you have your doubts about this, but let's go on. So here they give this example of browsing your social media and coming across a particular post that describes your experience on how to do something. Now, of course, different people with different personality will respond in different way. You will have an extroverted version where you have more focus on active communication, on group interactions, or you have an introverted version that is more quiet, building deep connections, smaller social settings. And of course, all this brings us back to the question, how does personality and the emotional influence that is expressed here in a linguistic text here interconnected? And can you use here, or can you detect here the emotion in a linguistic text? And if you want, deduct here what personality type are you facing? Now, the core idea is that, like in human, the personality and the emotions are deeply intertwined. The emotion expressed in a person's writing are a powerful signal of the underlying personality traits. And the idea is we can build now an AI model that learns this human relationship as a pattern in a self-supervised way, given we provide the AI machine enough training data. So we have self-supervised emotion labeling, and then we have a joint optimization. Simple, you have a shared encoder with 2 additional heads. One head is for the personality prediction and one head is for the emotion prediction. So you have an interlinked mathematical space. For the cross-attention, you want to model here the fine-grained interaction, allowing here the personality representation to be dynamically, quotation marks, modulated here by the inferred emotional signal. And you have star, I have a particular video on this self-taught reasoner, generates here the reasoning chain to explain its predictions. Key insight, the authors tell us, yes, we think it works. We have here, if you want, developed a personality detection model as an AI model that gives us now insight, analyzing here the emotional imprint of human text, and we can tell you what kind of personality it is probably that this human writer is in real-world experience. Proves that emotion is a critically important feature for understanding personality types from the text. And then we have a second paper. This is not the last paper. The University of Cambridge, Technical University of Munich, University of Toronto, and the Alan Turing Institute of the UK, September 4th. And they go towards evolved emotional policies for LLM agents in multi-turn negotiations. Now, this is a strange title. Emotional policies. Don't make a mistake. I thought, what the hell is this? Nothing. We are in reinforcement learning and we have policies, equals strategies for learning here particular patterns. And now the policies that we apply is not a simple linguistic text, but now we apply a policy now for learning emotions. Learning, of course, as a pattern matching machine. And now we have, if you want, a reinforcement learning methodology that the machine should learn to detect and interpret human emotions and mimic this here in an agent-to-agent communication so that your agent negotiating for a better price for a particular product on the internet is successful in negotiating here for a better price against another bot on the internet, the seller bot. Great. It is interesting how they approach this topic, and this is the reason why I think it's less the title, but the implementation is classic. No? We have evolutionary reinforcement learning framework, optimizes here the dynamic emotional expression in the negotiations. Beautiful. We have state transition, but now our state transition are not about any physical location, acceleration, velocity of objects or object permanence. Now we have in our state transition emotions as the objects. State transition into dynamic, again, we have a Markov decision process. Maybe a partially observable Markov decision process would be more intelligent, but never mind. The authors decided to go with an MDP. And we employ now a genetic optimization. Now, this is nothing with wet biology, genetic. This is just because we have a statistic of a population and we have an evolution of the mathematical population in the statistical interpretation, and therefore we call it a genetic optimization problem. So you see, no wet biology involved. let's continue with this sentence, to evolve high reward emotion policies. And you immediately detect this is classical reinforcement learning. We have here a reward function at the end. We want to have here the maximum cumulative future reward of the complete system. And we use now here our policies, our strategy to achieve with a particular mimicking of a pattern in our AI system to achieve here this best price, for example. So policies regards here strategies, and the emotion are simply the object of the state transition. So you see, I hope I could translate this here to a normal reinforcement learning AI speak. Otherwise, it gets a little bit complicated if you read this paper the very first time without some introduction. So, human decision-making systematically deviates, of course, we are just humans, from the classical economic assumption of pure rationality if you have a price negotiation, because we humans are dynamically shaped by some biases and some emotional states rather than we are absolute stable personalities with absolute logic like Mr. Spock. Now, in the computation, they use everything that we know from DPO and reinforcement learning, from human feedback and everything. But of course, you remember, this is only a reactive pattern. And the question is now more or less, hey, can we predict the future? And the authors tell us, LLMs currently lack here this hyper-meta reasoning about an emotional cause and effect sequence, thereby remaining rather reactive than generative in managing here some effective dynamics. Now, here's an image. So you have a price negotiation, you have a prompt for the seller, then you have a negotiation scenario, you have the prompt for the buyer, and then you have your agent, and maybe you have agent-to-agent communication. So you don't go as a human to the internet, you have your agent, and the agent will have now not only a logical pattern in its world model, but will have now emotions. So emotions are also pattern, if you want, for the AI. But now the question is, if you combine logic and emotion, is there something in the training data of the complete internet, how humans behave in these price negotiation setups, that a particular sequence of emotion would give you an advantage over your other bot? Simple. A little bit a strange idea, but simple from the policy. No? So the core idea, in a multi-turn negotiation phase, the sequence of emotion an AI agent displays now, contrary to its opponent, is not a random sequence, but it is a learned policy, a learned strategy, a learned sequence of, at first, being happy, then being, I don't know, whatever. You get the idea. So, and if you have learned as an AI machine an optimal emotional policy and receive the highest reward back, then you know you achieved your goal. Can be evolved to maximize the negotiation success, and you can buy this product on the internet for the cheapest price. I told you already, now we look at emotion as elements of a Markov decision process, which is a little bit strange to say this sentence loud, but okay. So the negotiation also is framed as an MDP, where the state includes here the turn number, the current emotional state, price history, you want to achieve a particular goal. Action is here the LLM response, and it is guided here by the particular policy the AI machine learned on the implementation and the deployment of particular emotional patterns in the negotiation process. Yeah, I told you already about the genetic algorithm. You have it here now in absolute detail. You see we have population and evolution and everything. If you want to have it here a little bit more in detail, this is for you. Otherwise, let's go to the key insight. So we can see an AI agent with an evolved, adaptive, emotional policy, which is a very strange sentence, but okay, it's the time. Consistently and dramatically outperforms agent with no emotional guidance. And you see, this is the whole reason of this video. 6 new AI papers tell me today, listen, we found if we imprint particular emotional patterns on our AI machines, we see that AI machines have a better performance compared to the other AI machines that are just hyperintelligence, that are just superintelligence, that are just AGI, ESI, E-Hyper-I, whatever. Just today I learned we have to include emotions in AI systems. Strange. Okay. Inside the Autostellus, this demonstrates us that strategic, dynamic, emotional expression are the key factor for advanced negotiation agents. Interesting. Part 4. The end. So, my summary of these 6 papers. Yes, we can build psychological AI agents, mimicking and mapping the experience from human psychology patterns, but it's not as easy as you might think. Because, yeah, we do have powerful, fine-tuned, free methods to instill, as I've shown you in the papers here, this Myers-Briggs 16 categorization and specific red teaming personalities into LLMs. And those personas are stable enough to be verified by some external linguistic text and can improve the performance on the task like red teaming and so on. But this personality thing on a machine is a little bit critical. And I showed you in the paper 3 and 4, the central revelation is that this is a personality illusion. Today's agents are expert actors. They can pass a personality test with flying colors, but they fail to exhibit the corresponding behavior in the real world under pressure, making decisions. So, linguistically, A+, actual doing, D-. So their self-reports are coherent, but their behavior is not, full stop. And the authors of these 2 papers tell us this is the single most important limitation to understand when deploying agents in high-stake real-world scenarios. But come on, we want to have AI in real-world scenarios. We don't want to limit our AI just for some, I don't know, linguistic benchmark test. Modern alignment, all this reinforcement learning, all we have for the training for learning multi-AI system creates good speakers in our multi-agents, but not coherent actors. So there is a clear, as I showed you, dissociation between the self-report and the actual behavior, suggesting that all the learning techniques that we currently know, like reinforcement learning by human feedback, optimize only for linguistic plausibility, but not for action, grounding consistent behavior of this AI agent. So therefore, what is the final insight for me after reading all this paper? Emotion is the next frontier for agentic AI. Those 6 papers have absolutely convinced me emotion do have an effect on the performance of AI system. Go for coding, for red teaming, wherever you start, or to some price negotiations. So emotion is shown to be a critical element from 2 angles. No? Key feature for understanding the human psychology and a powerful strategic tool for the agentic interaction and the expressionist and the negotiation benefits you can get from this. So agent that can understand and strategically deploy emotion, either in a human AI or in an AI interface, will be significantly more effective. This is the result from all 6 papers. Agents that understand how and can strategically really imply emotional patterns in their interaction with the environment will be more successful. This is it for today. I'm a little bit baffled. I don't really know how to integrate this particular piece of knowledge. But hey, subscribe, and I see you in my next video.